In this lesson, we have what should be a relatively short, quick lesson on reformulating Faraday's law now that we have knowledge of the self-inductance parameter. Well, we know Faraday's law in its traditional form, that the induced voltage that produces the induced current to fight, right, the negative here, Lenz's law, to fight the changing flux, because nature wants to maintain the status quo when it comes to changing flux. So the induced voltage is negative n, the number of turns in the solenoid, times the deflux dt that is occurring in the solenoid, and we did a lot of these types of analysis with Lenz's law in our last chapter. Well, if we bring the n in with the flux, so all we've done, let me erase these little additions here. If we bring the n in with the flux, we get d n flux dt. But remember from our last lesson, we have the number of turns times flux equals the self-inductance parameter times the current. So we can replace the n flux term with Li. L, as we have said, is a constant. In our next lesson, we will be seeing the derivation for the self-inductance of a solenoid. But the constant can come out of the ddt of Li. So we get negative L di dt. So now we have Faraday's law in terms of our self-inductance parameter. So the bigger the L value, as it says here, so please again get all of these annotations into your notes. The bigger the self-inductance parameter, the bigger the induced voltage, the stronger the solenoid. So Newton set us on the path of logic and cause and effect. And what we have here is very similar to what we've seen in past lessons, past concepts in physics, where we have cause, we have effect. The induced voltage, the induced EMF, is the effect. The cause is the changing current, which is the cause of the changing flux, which then creates the effect of the induced current, and we have our parameter L. So we're going to see that the L parameter we can give meaning to, just like we gave meaning, remember, way back in mechanics. Let's go way back into mechanics and just write down F. You don't need to add this to your annotations, but let's just do cause and effect. The very first one we saw, F equals ma, right? This was the cause. The force was the cause. The acceleration was the effect, and mass was the proportionality constant that linked the two. Remember, force is directly proportional to acceleration. M is the proportionality constant that links the two. We equated mass with inertia, so it was resistance to the effect. And we are going to see the same thing with Faraday's law in terms of self-inductance. We're going to see that this L parameter behaves almost in a similar sense to resistance, in that it's going to be how much the inductor is going to fight or impede. We don't call it resistance, we call it impedance. How much is it going to impede the changing current, which is the same as how much is it going to impede or fight the changing flux. So I know there's a lot of words and language that I just threw out there. We're going to understand it more in coming lessons as we break it down piece by piece. But Newton set us down really this royal road of logic, cause and effect, that is used all throughout classical physics, whether it's mechanics or electricity and magnetism, and that is why Newton is on the pedestal he is relative to what we know in physics, or what we do in physics. The last thing we have to look at in this relatively short lesson is the units for the self-inductance parameter L. If we look at our equation for Faraday's law up here, that the induced EMF, which is voltage, right? So the induced EMF here is voltage. di dt is amps per second. So that is where the amps per second comes from when we bring the di dt down. So we get seconds on amps. So 1 volt second divided by amp is honoring Joseph Henry, who was Faraday's counterpart in the United States. So 1 Henry is 1 volt per second. And notice that L absolutely, so make sure you get this in your notes, L can be measured experimentally by measuring the induced voltage. If you can, and we can, dictate the changing current, then L is our only unknown. So let me again pull back and erase some of my extra notations here. If you want the F equals ma cause and effect comments in your notes, you're certainly welcome to do that. But let me clean up the pages from all my little check marks while I was talking. And make sure you get down the basic annotations into your notes so that we can move on to the derivation for the inductance equation for the solenoid.